And welcome everybody to the Daily Space Weather. Today we're talking about Sunspot 2806 and how it has returned in fairly spectacular fashion here. Volcanoes, a volcanic uptick. What about Unzicker's real physics and some additional referrals? First thing we're doing is looking at the solar intensity gram to see Sunspot 2807 continuing to fade, but Sunspot 2806 reforming and producing another beta class sunspot group. So the likelihood of solar flares has gone up significantly as a result of that. And we'll be keeping you posted if anything exciting happens. Here's a composite view. You're looking at three wavelengths here, 335, 193, and 94 angstroms. Let me refresh that there. It's looking a little bit shaky. We don't want to cause any seizures for our viewers. And we've got some close-ups of that sunspot, and it's reforming and producing some flares actually in the past 24 hours as well. We'll get to it. Here's 193 angstroms. And the coronal hole wind stream from this coronal hole system has so far been a dud. NOAA forecasting geomagnetic storms, and all we really saw was a short period of geomagnetic unrest for about 6 hours. And we'll give you further details on that as well. More coronal holes rotating in the southeast. Here's a 304 angstroms full disk view. And we've got some minor filaments. Likelihood of coronal mass ejections is actually quite low right now. And here's 171 angstroms. And we're going to show you a close-up of this area in the southeast. Could be a rising sunspot. We see some filaments down there and some brightness. So here's a close-up of that. Filamentary behavior jumping around down there in the southeast quadrant. And let's move on to some more stuff here. How about a diagram of the solar system? Here at the Smash News Network, we want our viewers oriented as to what's actually going on. So here's where stuff is right now on the 7th. There's where things will be in 1 week. I like to use the planetstoday.com to produce this great visual on the daily. Now we're at in-the-sky.org, where I make myself my sky chart. I face mine to the south. I'm currently facing to the south. Which direction are you usually facing when you're watching our daily space weather videos? Let us know in the comments, as this is an interactive channel. And we do read all of our comments, and we respond to many, many of them on the daily. So the moon is up near the apex of the ecliptic. You'll also see Jupiter, Saturn, and Mercury. If you're up before dawn and you have a clear sky and no light pollution, as Mercury is pretty dim. And the radio flux has come up to 77 solar flux units. So an increase there in the radio flux coinciding with the re-emergence of Sunspot 2806. There's the radio flux in a 1-year context, which is this upper black line. And you can see how proportional that is to sunspot number with that red line. And I just wanted to show you the Space Weather Enthusiast dashboard. The NOAA forecast for geomagnetic storms and unrest has already subsided. Expecting a KP of 3 for the remainder of the day. No geomagnetic unrest or geomagnetic storms have been forecasted. Next, we're going to do volcanoes. Sort of an important aspect of the Smash News Network. Least busted name in news. Etna, Mount Etna on the island of Sicily, has once again erupted in a spectacular fashion. So the 10th paroxysm has been underway since last night, it looks like. expecting some ash fall along the eastern flank, including Zaffarana, Milo, and Giare. Aviation code has been raised to red. Degassed lava issuing from an eruptive fissure, cutting through the cone and flowing toward the eastern base. Also now, Fagradalsfjall on the Reykjanes Peninsula on Iceland. The situation remains tense there as hundreds of significant earthquakes have happened. We saw 397 quakes between 3 and 4 magnitude, 5 quakes of 5+ magnitude, and 51 quakes between 4 and 5 magnitude. A total of over 20,000 tremors have been recorded since activity started. Will it lead to another eruption? Let us know in the comments what you think. This activity continuing for more than a week now. Sakurajima on the Isle of Kyushu near Japan is also erupting, producing an 8,000-foot ash plume. Suwanosejima on the Ryukyu Islands, 6,000-foot ash plume there. Mount Raung on East Java, 13,000-foot ash plume there. Semeru, East Java, Indonesia, 13,000-foot ash plume there. Dakono exploding, 7,000-foot ash plume there. Veniaminoff on the Alaskan Peninsula has been exploding, 10,000-foot ash plume there. Pacaya in Guatemala, as well as Fuego. Pacaya exploding, 10,000-foot ash plume. Fuego has dispersed its volcanic ash according to satellite imagery. Sangay in Ecuador exploding, 27,000-foot ash plume there. Revenador in Ecuador as well, exploding, 15,000-foot ash plume. And the Peruvian volcano of Sabancaya producing continuous ash emissions, a reminder to not attempt to pole vault over or square dance around the caldera. Next, we'll go into the realm of earthquakes. Here's the USGS page, and we see continued significant aftershocks in the 5 and 6 magnitude range. A 6 magnitude quake used to be news, but now it's showing up just as an aftershock, so it's a pretty shaky situation there in between Fiji, Tonga, and New Zealand in the Kermadec Trench, just south of the Tongan Trench, which is really the same trench. And we're just going to scroll up the list here pretty quickly. There was a deep quake at Japan, a 4.3 magnitude at 211 kilometers, as well as a deep quake in Kamchatka, the southern tip of the Kamchatka Peninsula there. It's a 4.6 magnitude at 102 kilometers depth. And leave us a comment if you have theories about what the Earth is made out of. Mankind has not even drilled down 20 kilometers. And what the Earth's made of is kind of important. It's a subject we'll cover later on the channel. We won't get too into it in the daily space weather video. Here's a deep quake in Afghanistan, a 4.1 magnitude at 237 kilometers. So significant deep quakes kicking off. And here's the shallowest quake we've, I think, ever reported on the channel. Check this one out. It's a 3.2 magnitude at 3,400 meters above sea level. So over 10,000 feet of altitude, folks, there. And directly under the main caldera of the largest volcano in the world. It's Mauna Loa. So that is a significant earthquake there, again, at over 10,000 feet of altitude. Something like 2,000 feet below the ground there and 10,000 feet above sea level, over 10,000 feet above sea level. A 3.2 magnitude likely magmatic quake directly under the main caldera of Mauna Loa, Earth's largest volcano. Basically, the whole island of Hawaii is Mauna Loa, more or less. So tons of aftershocks there in the Kermadec region following that 8.1 magnitude quake a couple of days ago. Here's another 5+ magnitude quake on Iceland. And we'll show you the location of that real quick. And you can see not far from Reykjavik, just out in the sea there, just off the coastline. Also a 4.5 magnitude at Iceland, a 4.4 magnitude at Iceland. Here's an odd one. It's a 4.4 magnitude quake at Gabon. And we also saw a 5.2 magnitude quake there, well into the African craton there. Deep quake at the Philippines at a 4.7 magnitude. A deep quake in western South America, one of the most common spots to see quakes beyond 100 kilometers depth. And let's move on. By the way, this Smash stream was brought to you from twitch.tv/smashamash. It's a great streaming platform. If you're viewing on YouTube, don't forget to press like and subscribe over there. Thanks to our followers at Twitch and BitChute, etc. Most importantly, make sure you watch the YouTube channel as it has the most exclusive content. There are playlists there at youtube.com/smashamash/playlists. So check it out. And here's a clip from yesterday. We've got a new playlist called Do One Thing. And here's a little clip from yesterday's Do One Thing video talking about the fundamentals of running. And you should do one thing. If you're planning on doing something to improve your life, do it. Start with one thing. And don't be overwhelmed by your massive list of things you likely need to do.
Your brain will want to return to those naturally.
I was running uphill during that. Thanks again to our BitChute subscribers, which continue to grow, as our YouTube subscribers continue to oscillate between 1,750 and 1,740 subscribers. So just a little side tip before we do a cosmology segment. If you're not a content creator, you may not be familiar with this sort of thing. Our YouTube subscribers have oscillated between 1,750 and exactly 1,740 subscribers for the last week, going from 1750, 1740, 1750, 1740, 1750, 1740. I kid you not. I've not documented it because it's not really worth my time. Let's move on to a cosmology segment. We'll talk about a couple interesting things here that you may not have known about before. First, we're going to pick a random object between 1 and 1031 using our quantum random number generator. Today's die roll yielded a result of 684, which will coincide with something at the Neil Gehrels Swift Burst Alert Telescope. Let's see what it is. 684 coincides with XTE J1739-285, a low-mass X-ray binary/neutron star. Here are the X-ray transient outputs from it, and you can see a cyclicity there. And check it out, it's been actually building in its variability here in X-ray over the past about 10 days. You can see higher highs and lower lows over the past 10 days of activity there. That's the 30-day chart in the lower left. Let's take a look at this visually. Here it isn't on SIMBAD, so let's take a look at it in infrared on the 2MASS. And there is a black spot there where this high-mass X-ray binary/neutron star is located. Let's see if it shows up in blue light. And we see a heap and helping of nothing there. How about the multi-mirror project? And there we do see it showing up on the XMM, the multi-mirror X-ray project. How about Chandra? And we see a blip there on Chandra as well. We'll full screen that. And there's that high-mass X-ray binary/neutron star. Oh, low-mass X-ray binary/neutron star. We'll just refer to it as a massive radio source. That's today's quote random end quote object at the Neil Gehrels Swift Bat X-ray Observatory. Leave us a comment if you think absolutely nothing in the entire universe is random. Next, I want to talk about Unzicker's Real Physics. Here's a great article, 5 Years of Gravitational Waves, a Chronicle of Strange Coincidences. Now, this is on Medium. Cosmology.com. So perhaps have a read on this. Again, 5 years of gravitational waves, a chronicle of strange coincidences. So I've got some issues when it comes to the realm of gravitational waves, and Unzicker does too. We won't talk about it in depth here, but I just wanted to give you a quick reference here to Unzicker, and our regular viewers may be well aware of it as we put a community post up last night. We shared one of Unzicker's Real Physics videos. We'll play you a clip from that and refer everybody watching the daily space weather videos during this cosmology segment. So you can also find Unzicker on his own website, alexander-unzicker.com. Here's a clip from Alexander Unzicker's YouTube channel, Unzicker's Real Physics. If you're not familiar with beta decay, it has to do with what happens to a neutron when it's resting. And what happens with a neutron when it's resting is really weird. In about 880 seconds, it turns into a proton and an electron, traveling at relativistic speeds. Here's a small clip.
So people are thinking seriously about postulating a fourth, fifth, and sixth kind of neutrino.
And he's referring to neutrinos to account for the missing mass, which occurs when beta decay occurs. Yes, there's missing mass, folks. So the law of conservation of matter and energy comes into play when this becomes a thing. Watch the video if you haven't about beta decay. We've linked to it in our community posts. And if you're a subscriber, you should be. You may already know about it. And that's today's cosmology segment. Look for more about Mr. Unzicker in the future. Next, going back to current data, here is the GOES X-ray flux over the past 3 days, and you can see a series of small B-class solar flares here. This one's actually a mid-level, but not real major, and we've seen 4, actually 5, one kicking off once again as I did show prep here. And again, if you've got comments directly for the sun, just leave them in the comments thread. Perhaps we'll read them in the daily space weather. Shout out to the sun. Proton flux does not show any proton strikes. And let me check the life of the stream before I go on. And everything looks copacetic. Next, the real-time solar wind, a rather important variable when it comes to your space weather. And we see a very steady solar wind here over the past 24 hours. No major shifts in the density or the velocity, although they've both been coming down. Current solar wind density, 4.67 protons per cubic centimeter. Solar wind velocity still elevated from a coronal hole wind stream, but not particularly high, at 506 kilometers per second. KP index now down to 1, well below the NOAA forecasts. And for you new viewers, the KP index is a measurement of global geomagnetism. Those bars each represent 3 hours. Here's 4 hours of magnetosphere movies. We're looking at the magnetohydrodynamic density here surrounding planet Earth. And as solar protons rain down on the magnetosphere, you get some sort of an effect similar to this. This is based on the space weather modeling framework. Again, it's 4 hours of data. And it shows you likely locations of things like the Van Allen belts, the magnetotail, and the bow shock. Coming a little closer to home, here are ground magnetic perturbations. Again, it's 4 hours of data. If you want to realize where this comes from, check out the Geospace Magnetosphere movies. You can search for it. Scroll down to the bottom, find the Details tab. And within the Details tab, there will be a link to the Space Weather Modeling Framework. You can read all about where it comes from. And it comes from a lot of different data points. Magnetometers, Van Allen probes, the solar wind data, electron flux, and a lot more. So we let this play through a second time here as it refreshed. Again, 4 hours of data courtesy University of Michigan. Geospace model V2.0. So they've actually, we used to show V1.5, but now it's been upgraded to version 2.0. Here's 3 days of the GOES magnetometer as measured by the GOES 16 in the ionosphere layer. Fairly smooth here. And the Earth has moved into the South Pole-oriented current sheet. We'll show you that in the next frame. So here you can see the changeover from the North Pole current sheet shown there in green into the South Pole current sheet. And you can expect the Earth's potential field surface source lines shown there in orange to be in the South Pole current sheet for the foreseeable future. And it does indeed look like there is some activity rising in the southeast of the local yellow dwarf, otherwise known as El Sol, or the sun. So here's the ecliptic, the line of sight coronal hole plot. The previous slide was the ecliptic plane field plot. And the line of sight coronal hole plot shows you the sun's B field here in blue. Reference to previous slides, when we were looking at Geospace Magnetosphere Movies ground magnetic perturbations, we were looking at the Earth's B field, the strength of it on the ground level. Here's the sun's B field shown in blue. And you can see that North Pole-oriented coronal hole there rotating out of the Earth-facing zone, and another coronal hole rotating into the Earth-facing zone right here. It is a South Pole-oriented coronal hole. The current one providing the high-speed wind is that North Pole one. Now, if you haven't watched yesterday's video, we put up one called Solar Polar Fields Now versus 2010, completely incongruent to previous cycle field progression. Here's a clip. By the way, that is what this looked like exactly 11 years ago. So here's a clip from yesterday's video. If you haven't watched this, you can find it in our playlists. Again, youtube.com/smashomash/playlists.
Next, back to the graph. Here is Sunspot cycle 24.
And you can see the similarity in the sunspot number. Sunspot number is not the only thing we're looking at to talk about solar activity, folks. There are a lot of other variables besides things like solar irradiance and sunspot number and the radio flux, and we're trying to sort of make people a little bit more aware of that. And thanks for leaving a comment. Kathy Garden, good morning to you too, and have a good weekend. Thanks for tuning into the Smash News Network. Now, we normally show the coronal magnetic field plot here, the magnetic field plot of the sun's corona, and because we're seeing data that's 4 days old there, we decided to show you another portion of the Integrated Space Weather Analysis Center. This one is right on page 1, ASSA detected sunspot groups. So this will show you detected sunspot groups in real time, and it'll even show you the way the flare probability progresses. You can see there sunspot 2806 beta class sunspot. Moving on, here's just a diagram of the Van Allen belts. The Earth has 2 at most times. This is showing you also altitudes of spacecraft in miles, such as your GPS satellites, which are around 12,500 miles, and the SDO, which is more like 22,000 miles, in a figure-8-like orbit around this part of the planet here, just north of the equator there, around Baja California. Next, we're looking at charging hazards, as high levels of electron flux can charge up satellites. We don't see any of those, or particularly high levels of electron flux. Here's a 3-day chart of the electron flux as measured by the GOES 16. Having been well into warning levels here 2 days ago, and yesterday slightly into warning levels. Here's a 1-year chart of that to put the electron flux into context. And here's the forecast model. This is the greater than or equal to 2 million electron volt electron flux forecast. And we would expect today's observation to be a little bit below the prediction. Once again, the prediction there shown in the green box. Here's a visualization of the total electron content. Not showing any major anomalies, I don't think. I don't think. They don't pay me to think. They pay me to be a compliant sheeple. And here's a diagram of the atmosphere. Keep in mind this is in kilometers. And we show this daily to show folks where the F ionosphere layer is. It's around 300 kilometers altitude. It's where the GOES 16 makes its measurements. Here's a visualization of the ionosphere. This is a vibrational frequency. And this is at very low resolution, as it is only showing you a 1 megahertz resolution. It's not showing you decimals of megahertz. Each blob coincides with 1 megahertz resolution. Not looking particularly anomalous here today, looking pretty normal. Here's the current image. That's from 11:30 Universal Time. A little bit of a charge up happening there just west of India. Now, thanks to Catherine Abramson for leaving us a comment yesterday, I forecasted that this tropical system would break down. And let me just give you a little meteorology tip here, folks. If you see a cyclone or a hurricane or a typhoon or whatever you want to call it, a tropical cyclonic system, this is the surface winds. Take a look at it in the 250 hectopascals. If you do not see a jet stream component with that system, it's likely that it is not strengthening. Now, there are other factors that come into play, but all things being equal, in other words, if it's not moving into warmer water, or if there's not a lot of moisture about to connect with it, if it doesn't connect with the jet stream, it's not likely to be strengthening. So again, there are the surface winds, and that thing is broken down big time here. So let's go back to the 250 hectopascal winds and show the jet streams of both sides of the planet. So here's the eastern world. There are the jet streams associated with the eastern portion of the planet. Getting a little bit more normal here over places like the Indian Ocean, but still blowing backwards, east to west over the entire Indian Ocean. Here are the jet streams of the western world. And some very stagnant jet stream behavior there over places like South America continue. And we've got a major anticyclone right over the geographic North Pole. Check it out. Major clockwise rotation there. And as we continue on with meteorology, here at the Smash News Network, Least Busted Name in News, we like to show a daily real-time lightning map. It's from lightningmaps.org. It's where I go when I hear thunder. And we're seeing a continued lull in lightning here. Actually, very low levels of lightning over the past about 10 days. Here are pressure maps on windy.com. We're going to advance this into the GFS forecast. Here's where pressure cells are around now. And there's where we expect them to be at 12 noon tomorrow, Monday, March 8th. And that is 12 noon Eastern Standard Time. We are located in Lehigh Valley, Pennsylvania. Smash staff and I. Here's what's going on in the cloud layer. Low cloud still over a huge portion of the North Atlantic and a significant portion of the Gulf of Mexico. And let me just bring up the water vapor map. I must have forgotten to animate that. So again, there's the cloud layer, and here is water vapor. And when you're looking at a Doppler radar map and you don't know what's going to happen next, go look at the water vapor map. It's the NASA GOES Interactive Weather Satellite Suite, and it is indeed sweet. Some chaotic air masses here over the western portion of the U.S. This whole area right here is featuring multi-altitude pressure systems. And we can tell that just by looking at what the clouds and what the water vapor are doing. It's pretty chaotic, and it might yield some interesting cloud formations. Here's a U.S. Doppler radar map. Pacific Northwest still getting pummeled with lots and lots of moisture. Some snow showers over Pennsylvania and New York. And we saw a lovely snow squall yesterday here in Lehigh Valley, PA. And if you're wondering where Lehigh Valley, Pennsylvania is located, it's right about here, practically within smelling distance of New Jersey. And thanks, smAsho team, for tuning in. Don't forget to tell your friends, your foes, your science noobs, and your science pros about the channel, as we're tanking over here, and we are completely in the red. So we need your assistance, as the algorithms have been manipulating our subscribers from 1750 to 1740 for over a week at exactly either 1750 or 1740 every time we look. So please share the content with your friends, your foes, your science noobs, and your science pros. Speaking of science pros, our patrons are science pros. So thanks for being patrons and increasing the probability that these videos will continue to exist and be publicly visible. Please consider becoming a patron at patreon.com/smAshomash. It greatly assists us in having some kind of a clue as to what our income will be as a result of making these videos, where we make just about nothing on YouTube. And thanks for leaving a comment, Amp Mods. Bye. Again, please press like and subscribe on YouTube. Seriously, folks. Press the notification bell. Press share. And leave us a comment. It doesn't have to be nice. You're not going to hurt my feelings. Here comes some bonus features. We're going to show you the latest high-res magnetogram and the latest high-res intensitygram. So here's the intensitygram, and you can see Sunspot 2806. It's got a South Pole leading umbra and a North Pole trailing umbra, which makes it beta class. Likelihood of solar flares has gone up. We're not expecting any significant coronal mass ejections. Here is the magnetogram of Sunspot 2806, the reincarnated sunspot. And we've got close-ups of that to close things out. Here it is in 193 angstroms. A fantastic view. And you should see a couple flares happen there. Probably about 4 B-class flares. They're not that bright. It may not show up that well in 193. Here's 94 angstroms. This is more likely to show you the flares a little more brightly. 94 angstroms takes 10 images per minute instead of only 2 images per minute. And indeed, the solar flares are a little bit more visible in this wavelength from the SDO, the Solar Dynamics Observatory. And last but not least, my favorite wavelength, 171 angstroms. Anyway, thanks for tuning in, everybody. Remember, stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. Seriously, don't drive. And since it'll never be now again, visit our links. Welcome to the Neo-Renaissance, smAshomash.com. And may that solar wind be at your back and that nonsense absent from your YouTube subscription feed.